Welcome back, everyone. This is Dr. Gallenstein. In this lecture, I will be talking about indifference curves. Indifference curves. All right, this is building off of what we were just talking about in the last lecture, where we introduced the concept of preferences in a more mathematical way, and then used those to kind of describe the characteristics of a utility function. Okay, now what we're going to do is we're going to build on that, and we're going to continue exploring preferences. And specifically, what we're going to do is we're going to look at and try to model agents' preferences between two goods. Okay, and what we're going to do is we're going to explore what we call indifference curves. Okay, to do that, let's begin first by showing a utility function. And this utility function is going to be a function of two goods. Okay, so it's going to be a utility function. It's going to be a function that gives utility as an output. Utility function as a function of two goods, we'll say G1 and G2. All right, so these are two different goods, good 1 and good 2. In fact, we could make it a little bit less bland and maybe come up with some goods. So let's say a rather cliche example. Let's say coffee and bagels. Okay, so let's say coffee and bagels. Okay, so now what we're going to do here is we're going to say that this utility function is modeling. It's modeling an agent's preferences. We can use it later, as we'll find, although not today. Later, we can use this to try to describe their decision-making as to how many cups of coffee and how many bagels to buy. But let's hold off for that for now. We're saying this is modeling an agent's preferences. This function is going to describe how much utility they derive from the number of cups of coffee that they drink and the number of bagels that they eat. Okay, so here is our utility function. It's a function of two different things, of coffee and of bagels. All right? Okay. All right, so here we go. This is a utility function, and it tells us how much utility people derive from consumption of coffee and bagels. All right, so let us imagine that we held utility constant and we graphed all of the possible combinations of C and B, coffee and bagels, that give the agent the same amount of utility. All right, now this is something that we would call an indifference curve. Let me illustrate it. All right, so this is what we're going to do. I'm going to put it over here. I'm going to have some math on the left, and I'm going to have the graph on the right. All right, so what we're going to do is we're going to graph these two. We're going to have coffee down here, and we're going to have bagels up here. All right, this is what we're going to say. So let's say that we have a utility function. It's a function of coffee and bagels. And then let's say that we held the amount of utility constant. And then we wanted to show a graph of all the possible combinations of C and B that would give this agent some fixed amount of utility U bar. All right, so that's what we're going to do. We're going to plot this out. All the possible combinations of coffee and bagels that give this person the same amount of utility. All right, so here's the curve. We'll label it I, maybe I1. That I1 stands for indifference curve 1. I1 equals, indifference curve 1. Okay, so here's a curve. What this does is it describes all the possible combinations of coffee and bagels that give the agent some fixed amount of utility, or some constant amount of utility. And in fact, every combination here we call a bundle of goods. It's some combination of coffee and bagels. So for example, this point here is a combination of coffee and bagels. Okay? All right, so it's C1 and B1, whereas this point here is a different combination of coffee and bagels. C2, B2. So you can see that, and let's give this a label, A and B. So at the point A, the agent gets C1 cups of coffee and B1 bagels. At B, the agent gets C2 cups of coffee and B2 bagels. Now what we would say is that the utility that the agent gets from this combination, so C1, B1, is equal to the amount of utility they get at the bundle C2, B2, and it equals some fixed amount of utility that we call U bar. All right, because they both lie on the same indifference curve, the agent gets the same amount of utility from both bundles on this indifference curve. Now we could even imagine, so let's imagine we have a utility function. In the last lecture I mentioned a couple different utility functions that have the same that have the necessary characteristics. So let's say our utility function of x, let's say this. Our utility function of c and b was equal to the square root of c times b. Let's say that was our utility function. Okay, and so let's say that c1 equals 1 and b1 equals 3. And let's say that c2 equals 1 and, equals 3 and b2 equals 1. In this case, the utility of 1, 3 equals 3, square root of 3, which equals the utility of 3, 1, which equals square root of 3. So this would be an example of two bundles that would both lie on the same indifference curve. This bundle, where 1 and 3, gives me the same amount of utility as this bundle, 3 and 1. And so these two different bundles, these two combinations of coffee and bagels, both give me the same amount of utility. Okay, so these are examples, these are fair examples of this is an example of a utility function, and these are examples of bundles that lie on the same indifference curve. That means the agent is indifferent. The agent is willing to have 1 cup of coffee and 3 bagels, or 3 cups of coffee and 1 bagel. They're indifferent between them. They get the same amount of utility from both, and so they are not concerned with whether or not they have 1 and 3 or 3 and 1. 1 cup of coffee and 3 bagels, or 3 cups of coffee and 1 bagel. They are indifferent between them. So that's what this curve shows. The indifference curve is all possible bundles that achieve a given utility, U bar. That means agent is indifferent. Between any bundle on this. That means bundle A, the agent is indifferent between bundle A and bundle B. That doesn't mean that they don't have a preference. It means their preferences are well defined and they are indifferent. They have well-defined preferences, and their well-defined preferences are that they are indifferent between A and B, and any other possible bundles, any other pair of bundles that lie on this curve. All right, so that's what an indifference curve is. Now let's press this forward, and let's try to understand why this can be interesting. All right. So first, I'm just going to erase it all and start over. So it was something clean. All right, so indifference curves, utility function, coffee and bagels. Okay, the difference curve is all the possible combinations of coffee and bagels that give me the same amount of utility. All right, so it's all the possible combinations of coffee and bagels that give me the same amount of utility. So we'll call this indifferent curve 1. All right. Now, let's be clear. There are many different indifference curves. So let's give another example. We could have an indifference curve that's out here. We'll call it I2. The agent is indifferent between any bundle that's on this difference curve. The agent is indifferent between any two bundles that lie on this indifference curve. And the agent is indifferent between any two bundles that lie on the original indifference curve. So the agent is indifferent between A and B, and the agent is indifferent between C and D. Because the utility derived from A is equal to the utility derived from B, and the utility derived from C is equal to the utility derived from D. They're indifferent. Okay, so we can say that let's do this. That the dark blue utility function corresponds to some given level of utility U bar 1, and then the light blue utility function corresponds to some other utility UCB. All right. Now, looking at this, I might ask the question, what indifference curve corresponds to a higher level of utility? Another way of putting it would be, what's larger, utility level U bar 1 or utility level U bar 2? Which one is higher? Which one's larger here? So fill in that space. Which one gives you more utility? Do agents get more utility from bundles on I1, or do they get more utility from bundles on I2? And is there any way that we can know? Just from looking at this graph, is there any way that we can know? And now that you've thought about it, I'll show you. It's actually very perfectly clear which indifference curve gives you more utility. There it is. It's actually very clear. The agent gets more utility from I2 than from I1. How can that be? How do we know? Why is it so clear? Well, it's clear because more is better. It's clear because more is better. Remember our third axiom? More is better. As you go farther out in this graph, you get more coffee and you get more bagels. That means that any bundle on I2 is going to give you more consumption than any bundle on I1. Therefore, we know that you derive more utility if you are on indifference curve 2 than you do if you're on indifference curve 1. Okay? That means utility is increasing as you move farther away from the origin. All right? So utility increases as you move away from the origin. All right. So we know you get more utility from I2 than you do for I1. Okay, so there we go. We've got that. Now let's press on it a little bit more. All right. The next thing I want to look at is I want to look at these indifference curves, and I want to show I want to demonstrate transitivity here, and I want to show the implication of transitivity using these indifference curves. All right, so again, I am going to, let's see, actually, no, I think I can keep this graph. I'm just going to do some erasing. All right, so let's do some erasing here. All right. All right, and I'm going to erase this indifference curve. All right, so now let me ask you a question. Can indifference curves cross? Can indifference curves cross? Let me ask you that question. And let me illustrate what that would look like. So let's imagine we had the second indifference curve and it looks like this. So here's I2. So a different I2, okay? And so here we have A, okay, and here we have B. Can indifference curves ever cross? What do you think? All right, well, I will go ahead and spill the beans, and that is because of transitivity, no, they cannot cross. Why? Well, let's demonstrate. Now, by looking at this indifference curve, we know some things. First, we know that agents will derive more utility from A than from C. That's very clear, so let's write that out. Agents prefer A to C. So we know that. I have a hard time drawing these in a way that I like. Okay. Agents prefer A to C. Okay. We also know that agents are indifferent between A and B. Okay. Different A and B. We know that agents prefer D to B because D is farther away from the origin, right? So utility goes up away from the origin. So we know that agents prefer D to B. Okay. And then lastly, we know that agents are indifferent between C and D. So let's put this together. Let's put this together and see whether or not we violate transitivity. So A is indifferent to B. And actually, why don't we even put this? Why don't we even put this in terms of utility? So agents will derive, so the utility that agents get from A is greater than the utility that they get from C. The utility that they get from C is equal to the utility that they get from D. The utility that they get from D is greater than the utility that they get from B. And the utility that they get from B is equal to the utility that they get from A. Does this violate transitivity? Does this violate transitivity? Well, I think it's pretty clear that it does, because it would imply this. It would imply, so if transitivity holds, it would imply that UA is, you get more utility from A than from B, right? So if we just, let's just cut out some things. Let's say, all right, so A is, you get more utility from A than C. C is the same as D, and D is bigger than B. So let's, if we just kind of chopped out this, we would get this, right? A is greater than B. But we know that you get the same amount of utility from B and from A, and therefore this would violate transitivity. All right, so it cannot cross. They cannot cross. This does not work. This is not consistent with rational choice theory utility functions. Okay, so that's kind of a demonstration of transitivity. A little more to go. Okay. So now, one really nice thing about indifference curves, I'm just going to draw an indifference curve here, between coffee and bagels. A nice thing about indifference curves is that they allow us to understand trade-offs between coffee and bagels. It allows us to understand the trade-off between coffee and bagels. It allows us to understand how many cups of coffee would you be willing to trade for an additional bagel. We can use these indifference curves to understand the trade-offs that people face between more coffee and less bagels, or more bagels and less coffee. All right, so let's explore that. And by doing that, we are going to explore a concept called the marginal rate of substitution. We're going to explore the marginal rate of substitution, okay? And this is going to be all about the trade-offs between goods. All right, so let's explain this. All right. So the marginal rate of substitution is the number of goods that an agent is willing to trade to get more of the other good. Okay, so we could put it this way. We could say, how many bagels is the agent willing to trade to get an additional unit of coffee? So in fact, we might even be able to write this function and say that this function is bagels as a function of coffee. All right, so we have coffee and then bagels as a function of coffee. So now I want to know how many bagels will the agent be willing, let's see, how many bagels will the agent be willing to trade to get an additional cup of coffee? All right, how many bagels how many bagels would they be willing to trade to get an additional cup of coffee holding utility constant? So this is, right, utility constant. This is just pure trade. All right, how many bagels would you be willing to trade to get an additional cup of coffee if this indifference curve is describing your preferences for the two? All right, remember this indifference curve. I'm gonna draw this in blue. This indifference curve is based on the utility function for coffee and bagels. Okay, so how many bagels am I willing to trade to get an additional unit of coffee? Now, whenever I say one additional unit, that should light an alarm should go off in your head and say this is marginal analysis. I want to know what's happening on the margin. I want to know how many bagels do I need to trade to increase the number of cups of coffee by 1. So what is how many bagels am I willing to trade for a marginal increase in cups of coffee? All right. Now this is going to be called the marginal rate of substitution. All right. But when I'm talking about the margin, we can always then move into derivatives. All right. Because if I wanted to say, how many bagels am I willing to trade to get an additional unit of coffee? Another way of putting that would be, how many bagels would I lose if I increased my coffee consumption by 1? All right, so then let's put that into the form of a derivative. This would be the derivative of bagels as a function of coffee with respect to coffee. This would be, we can put this in different ways. This would be how many bagels I would give for 1 more coffee. Or I could put another one. How many bagels I would give up by increasing my cups of coffee by 1. All right, so how many bagels I would give for 1 additional unit of coffee, or how many bagels I'd have to give up by increasing my cup of coffee consumption by 1. All right, so this is the marginal change. This is the marginal change in bagels given a marginal change in coffee. We call this the marginal rate of substitution. Marginal, that means it's changing on the margin. It's a derivative. Just as a side note, in case this hasn't been perfectly clear, whenever we talk about margins on the margin, that usually is going to imply that there's going to be a derivative somewhere. All right, because the derivative is the marginal change in the function f given a marginal change in the variable x. All right, so just keep that in mind. All right, so this relationship, the derivative of bagels with respect to coffee, is going to be the marginal rate of substitution. Let's go back to Brown. The marginal rate of, I picked the wrong Brown. It's the marginal rate of substitution. Why do we call it the marginal rate of substitution? Well, it's substitution meaning that we're substituting, we're trading between bagels and coffee. It's marginal, meaning it's how much we have to trade. It's the rate, that means, again, how much we have. Okay, let's put it this way. It's a rate because it's how much we have to trade, and it's marginal because it's how much we have to trade on the margin. That means how many bagels I have to trade to get 1 more cup of coffee. It is the derivative of this function. So if I am here, let's say I am at point A, I'm at bundle A, the derivative of this indifference curve is going to give me the marginal rate of substitution. This is the marginal rate of substitution. That is, how many bagels I need to give up to get an additional cup of coffee. Likewise, down here. So let's say this is point B. This has a derivative. You take the derivative, this is the marginal rate of substitution. That means how many bagels I need to trade to get an additional cup of coffee. This marginal rate of substitution, is the derivative of the indifference curve. It is the derivative of B bagels with respect to coffee. This marginal rate of substitution tells me how much I'm willing to trade. Trading between these two goods. All right, we're going to go a little bit deeper into this and deeper into the intuition here. But first, we need to derive the marginal rate of substitution. That means I need to calculate. I need to show you how we get this. We can calculate this. We can derive this. And that's what we need to do next. All right, so I'll pause there for a second. You can take a screenshot of this if you want to keep track of these notes. I might even save this one. This is just in case. Let's see. Okay. All right, so then let's clear this off. And now we need to derive. I want to derive the marginal rate of substitution. I'm going to draw the graph up here in the corner just so we keep it in mind. Coffee, bagels as a function of coffee. All right, the indifference curve. All right, the marginal rate of substitution is the derivative. Okay. And so we want to be able to calculate, what is the derivative of B with respect to C. This is what we're looking for. We want to find this. We're going to derive it. All right, and I'm just going to show you how we derive it. So this indifference curve, let's put it in blue. This indifference curve is, as I mentioned before, it's u bar equals u of c and b. All right, that is, it's a utility function with the values c and b at a given utility level. All right, so now I can use this to derive or to calculate, to derive this marginal rate of substitution. How would I do that? Well, first, let me rewrite it real quick. C, and then I'm going to just represent here that b is a function of c. And in fact, just maybe make it more clear, I'm going to rearrange this c and then c. Okay, so here we go. B is a function of c, and then we have c. Now, when you look at this, I'm hoping that in your mind some red flags are going off here, because I'm hoping that you're going to look at this and you're going to say, oh wait, I can take a total derivative of that. Okay, I'm hoping that's going off, because that is sure fire what we're going to do. So let's take a derivative of this. Derivative of that utility with respect to c. All right, so chain rule, total derivative, first the chain rule, derivative of u with respect to b times the derivative of b with respect to c, plus the direct derivative, the derivative of u with respect to c. Okay, so there's our total derivative. Total derivative. All right, we're going to use that total derivative to derive what we're looking for. First, notice this total derivative includes what we want. There it is, the marginal rate of substitution. Now we just need to solve for this, and it's going to give us the equation for the marginal rate of substitution. All right, so let's do that. First, we need to recognize that u bar is a constant, right? Because along the indifference curve, you always get the same amount of utility no matter where you are at on the indifference curve. So u bar is a constant. That means the derivative of it is equal to 0. That means this all equals 0. That's the first step. With that in mind, I can now solve this just using algebra. So let's take this to the other side. So we'll do u b times derivative of b with respect to c equals negative derivative of u with respect to c. Now divide both sides by this, and we will get the marginal rate of substitution equals derivative of b with respect to c equals negative the derivative of utility with respect to c over the derivative of the utility with respect to b. Now you'll notice here that this is the marginal utility of c. So that means here's the derivative of the utility function with respect to c. It tells me how much utility goes up given a marginal increase in c. And the same thing you'll notice here is the marginal utility of b. That means how much utility goes up given a marginal increase in the number of bagels. So let's just replace that. We're going to replace it with some notation here. This will be negative the marginal utility of coffee divided by the marginal utility of bagels. So to summarize all of that, I'm just going to put it here. The marginal rate of substitution is equal to the derivative of b with respect to c equal to negative the marginal utility of c divided by the marginal utility of b. All right, so there we go. We've solved it. We've calculated it. And now we can use this to give us some intuition, to give us some thoughts, to take our intuition, our thought train here deeper into decision making. Okay, so let's do that. This is the last thing we're going to do. I'm almost done. All right, so pausing for a second. You can take a screenshot if you want this. I do these calculations in the notes, but you might also like it presented here, so take a screenshot if you'd like. Okay, let's erase it. And let's throw this up here again. The marginal rate of substitution equals the derivative of b with respect to c, which is equal to the negative marginal utility of coffee divided by marginal utility of bagels. All right, so there's there's my marginal rate of substitution. What does this tell me? This tells me how many bagels I will trade for one more cup of coffee. Okay, now let's just discuss this for one more second and take this understanding a little bit deeper. Because the fact that the marginal rate of substitution is a function of the marginal utilities of the goods is very interesting. And so it can give us a little bit more depth into our understanding of economic decision making. Okay, so let's think about this. The marginal rate of substitution is the ratio of the marginal utility of coffee to the marginal utility of bagels. What does that tell me? All right. So let's think about it. Let's okay. And actually, let me throw up here the graph because I think it'll make it more clear. All right. Okay. Now, so let's go through and so let's illustrate some things. First, if we are at a bundle, let's say we're at this bundle here. Let's say we're at bundle A. At bundle A, we have I'm going to switch to a different color. Let's go orange. If we're at bundle A, we have a lot of B. So people already have a lot of bagels here. At bundle A, they have a lot of bagels in few cups of coffee. All right, at bundle A, they have a lot of bagels and few cups of coffee. Now let's just think about that. What does that mean about the marginal utility of bagels? Remember, I'm going to draw a margin. I'm going to draw this. Okay, the utility that I get from bagels as a function of bagels. All right, and this is probably going to look something like this, right? Remember. Okay, it's going to exhibit diminishing marginal utility. It's always going to go up, so non-satiation. It's going the derivative of u with respect to b is always going to be positive, and the second derivative of u with respect to b is always going to be negative. All right, so it's always increasing, but it's increasing at a slower rate. All right, and so if I have a lot of b, so that's what's happening at A. At point A, I have a lot of b. What does that tell me about the marginal utility? What's the slope here? What's the slope here? The slope is very shallow. That means at A, the marginal utility of B is going to be low. So the marginal utility of bagels will be low at A because they have a lot of bagels. They already have a lot of bagels. So the marginal utility of bagels will be very low at point A. All right. Well, what about C? At C, they have, at point A, they have very little C. Very, very, very little C. So I'll just draw that down here. Okay. And the utility curve will look something like this. Again, let's make sure that doesn't ever decrease. Okay. And just as before, it's going to have the exact same properties, right? So it's going to be increasing, but it's going to be increasing at a slower rate. It's a diminishing marginal utility, so it's negative. Okay, so there we go. Now, we know that the marginal utility of bagels at point A will be very low. But the marginal utility of coffee, on the other hand, will be really high. That means they're going to get a lot more value from an additional cup of coffee because they have very little coffee to begin with. So that means the marginal utility of coffee will be high at A. What does that mean? Well, let's plug this in. Let's give some intuitive understanding. So here's the marginal rate of substitution. Let's say the marginal rate of substitution at point A. So the marginal utility of C is going to be large. How should I illustrate this? I'm gonna illustrate this maybe in a silly way. The marginal utility of C will be large, and the marginal utility of bagels will be small. Okay. What does that mean? That means that that this is going to be a large negative number. That means the magnitude of this number, the absolute value of this marginal rate of substitution, will be very high, and because it's negative, it's a large negative number. Well, that's pretty intuitive. Let's look at the graph. What is the derivative of this indifference curve at the point A? Well, it is a very steep negative number. This means that at point A, the agent will trade a lot of B to get more C. Why? Because the marginal utility that they get from bagels is very low. They don't really care about those additional bagels. But the marginal utility they get from coffee is really high. They really want at least one more cup of coffee. And so they will trade a lot at point A. All right, let's reverse the intuition. We'll do it quickly. What about at point B? What about at point B? Well, at point B, they have few of B here, and they have a lot of C, a lot of coffee, few bagels, a lot of coffee. That means that the marginal utility of bagels will be very high, and it means that the marginal utility of coffee will be very low, which means the marginal rate of substitution, if we go back and use our same kind of illustration here, the marginal rate of substitution at point B will be equal to marginal utility, I've got it backwards. All right, the marginal utility of B will be very high, while the marginal utility of C will be very low. And so what that will mean is that I am willing to trade very few bagels to get an additional cup of coffee. One more cup of coffee doesn't help me very much. I already have a lot of it. And I have very few bagels, which means one bagel means a lot to me. And so I'm not going to be willing to trade very many bagels to get an additional cup of coffee at point B. The derivative at point B is much more shallow. It's a much smaller negative number. All right? So that kind of gives us some intuition as to the relationship and how marginal utility affects the trade-off between goods. All right, so that's indifference curves for you. Hope you enjoyed the lecture. Let me know if you have any questions, and I hope you have a fantastic day.